All right. Hello, everyone. Welcome to Next, and thanks for joining us. My name is George. I'm a product manager at Google, and we're at the final stretch here to talk about an exciting topic on agent context engineering for production. I'm joined by my colleague, Kimberly, and we're also joined by our friends from AT&T, Jeff and Preethi, who'll be discussing, how they developed and applied context engineering techniques using Google Cloud with one of their agents in production today. So we're in a major evolution in AI. We're moving from models to agents, and that shift has enabled us to do quite some amazing things, including automating complex long horizon tasks, accelerating software and product development using coding agents, and also delivering continuous personalized user experiences with agents that remember who we are. But before we talk about agents, let's quickly talk about models. LLMs are inherently stateless, right? They're great at generating text, but that's about it. They can't access real-time information. They can't read your database. They can't plan out or execute multi-step tasks. So every agentic technique that exists is to overcome one or more of these limitations. And we all know that models offer massive context windows. And this creates an illusion that more context is always better. However, just because we can use all that space doesn't mean that we should. As the chart describes, regardless of what model you use, including the latest state-of-the-art models, the more tokens you input into the context window, performance degrades significantly. And this phenomenon is known as context rot. So if we can't use or build a bigger brain with more capacity, what do? We need to give it a body. This is often called a harness or a scaffold. So we're transitioning from a single model architecture where the interaction between the user and the model tends to be more linear in nature, and also it's stateless and static. Here, prompt engineering is the technique that you have to be adept at. But now, in the era of agents, where we have multiple agents working together autonomously, we need to have an orchestration layer that manages context and information across the board. And this is done via skills, tools, and memories. Skills augment system instructions and basically provide this reusable and modular flexible components to instructions and tasks. Tools essentially provide agents with the ability to search information in the web and also real-time information. And this ultimately goes beyond traditional RAG systems as well as manual file uploads. And memories enable agents to persist their knowledge across sessions over multiple conversations in a long period of time. So in addition to prompt engineering, we need to be adept at what's called context engineering. And context is quite literally everything that we need to make agents what we want them to do or what they want them to be. It not only defines the task, but it also defines the data available to inform that task. And this allows the agent to go from simple task execution to more complex, robust task execution that is all autonomously conducted. However, it's not that simple. Context engineering is challenging, as many of you know. First, it's really hard to decide what to include in your agent's context, including the historical context that needs to be maintained. For instance, you may have needlessly bloated MD files that span several lines of code that can ultimately bury the most important things that matter to your context, such as constraints, instructions, APIs, etc. Second, without durable state management, it's really hard for your agent to maintain coherent context. So a simple disconnect or a page refresh, for instance, can wipe out your agent's working memory. And third, for your orchestrator agent, it's incredibly hard and non-trivial for it to select the right tools, the right skills, and sub-agents at the right time. So vague tool specifications or definitions, as well as skill definitions and specifications, can lead your agent to be mixing up its own actions and also guessing all the time. Obviously, the worst thing you can do is to give your agents bad context. This phenomenon is known as context poisoning. But everything else is about finding the right balance, finding that Goldilocks zone for your agent context. Too little context will cause it to hallucinate, also have fragmented reasoning based on outdated facts, and it will have this weird behavior of constantly asking you for clarifying questions. Too much context, as we discussed earlier, will create too much distraction and noise and provide context rot. In addition, it will have slower response times, and you won't be happy with your API bills. So all of this leads to bad outputs. And it's important to note that bad outputs compound with long horizon tasks, where we reap the most business value and benefit from. And this is because agents don't make a single decision at a time. They may make dozens at a time, either asynchronously or sequentially, depending on how you designed your agent. Let's take an example of a single agent that has a 95% accuracy score, whatever evaluation metric that you care about. This is commendable and even production ready. However, let's take that to the power of 3, and you're down by nearly 10 percentage points. So that is not production ready. So just a little bit of bad context can snowball into a pretty material and significant bad plan, ultimately making your output utterly unusable. So you're getting 0 ROIs for all those tokens spent. So the goal of context engineering is clear. It is to give exactly the agent the right information in the right structure at the right time, so the agent can reliably complete high-value tasks with minimal errors and supervision. It's much like packing for a weekend getaway or for our next conference, where you have a dresser full of clothes and you're trying to put everything into the suitcase. You don't need to do that. You only need to provide the necessities in your suitcase. And just for fun, this is a snippet from Peter Steinberger, the creator of OpenClaw's own SoulMD file. It admits the core reality that agents doesn't have a continuous stream of consciousness, unlike we do, unlike humans do, right? And this is because context is not preserved for agents. They're consistently being reconstructed at every session. So with that, I'm going to invite my colleague Kim to the stage, who is also the tech lead for Memory Bank, which she'll be talking about. And she'll be sharing how all these concepts come together in the context of our Google ADK agent framework, as well as Gemini Enterprise Agent Builder platform. Over to you, Kim.
Thank you. So now that George has introduced what is context, why it's important, and why it's complicated to actually build it, let's discuss some strategies to actually dynamically building this context window. Because ultimately, you want only the context that's necessary to answer this specific question for this specific user at this specific point in time. So we'll cover 3 different strategies to dynamically manage your context window, including tools, skills, and session compaction. So tools have been around since the beginning of agents. And tools are essentially an executable function that the agent decides to invoke to perform an action. That action can be sending an email, but in the terms of context engineering, you can think of it as a decision to retrieve external context to augment the context window with real-time information, whether that's from a RAG engine or a memory bank or some other source of knowledge. In order for the agent to know which tools it has available, you need to provide a schema definition for each tool that the agent has available. This schema definition can be quite verbose because it includes definitions of when I should call this, and then also the parameters that the agent should populate to actually invoke this function. And so as your agent intelligence increases, the token usage for each tool actually increases as well. And with with tool-heavy agents, a lot of that intelligence of your agents is actually buried in the tools and not necessarily in the agent itself. So one newer strategy towards managing the context window is actually using skills. So skills allow you to dynamically pull in domain expertise and dynamically populate your agent's context window with instructions that are relevant to the task that it's performing. So unlike tools where you're pulling in or you're including that all of the tools that you have available system or tool definitions, you're only providing what we call level 1 metadata. And level 1 metadata is a title of the skill and a description of when you might want to use this skill. Then when the agent decides to invoke this skill, the full metadata of the skill is actually loaded into the context window. And this process is called progressive disclosure. So you're basically dynamically managing the context window so that you're only pulling in the context that you need when necessary, and you're making your agent experts in different topics without overloading it with information from the beginning. So we've actually found that skills are a much more efficient way with respect to token management to add capabilities to your agents compared to tools. And both of the previous approaches that I mentioned are additive. You're adding context to your context window. But as your conversation gets longer and longer, you have all of these previous turns and context that kind of can pollute your agent's context window if you go too long. So it's also important to throw old context out. And if we're talking about a single session, you generally use something like context compaction. So with context compaction, you're looking at all of those previous turns of the conversation and throwing out stale bits. And what's important is, what if that first turn of the conversation was super important context and you don't want to lose that information? You can use strategies with ADK to actually dynamically summarize the information, or you can use memories to extract meaningful information from the content to then inject into your context window. So then you're kind of getting the best of both worlds. You're throwing out all of that verbose extra context that you don't really need while still maintaining what's meaningful. And let's put this all together now. So ADK has this concept of a working context. It's ephemeral, so it's thrown out after every invocation of the model, and it's kind of built just in time. So there's two different entities that really plug into this context. The first is your conversation history, which is generally stored in a session storage like agent platform sessions. So the session history is a very, very verbose, turn-by-turn log of all of the conversation. You probably don't want to include all of that, especially, again, as your conversation gets long, so this is where compaction comes in. Then you have some of your more developer-provided content, which also can be dynamic. So that can be the system instructions that you're defining what you want your agent to do. It can also be tool definitions that we covered previously, and then skill definitions as well. And then you can also pull in agentic memories in both places. So if you decided to invoke like memory bank or some other memory storage to retrieve memories, that would be part of the session history. Because it's a tool, you invoke that tool and it's added to the session history. But then you can also dynamically add memories to your system instructions so that you can initialize the interaction between the user and the agent. So now that we've covered how to actually stuff that context into the context window, let's cover one strategy for building this context so that's available at the time that you need it. So basically, how do you do the work in the background so that you have just the context you need available so that you're not doing it when you're in the hot path? One strategy to do this is with agentic memories. So with memories, you're taking a long verbose conversation, you're extracting what's meaningful from it, and then you're propagating that to future sessions, and you're also maintaining that context that you have available based off of the new sessions that you're coming into play. And so with that, I'll cover Agent Platform Memory Bank, which is a managed product that you can use to manage long-term memories. So with Memory Bank, your agent will write events to Memory Bank. You can decouple ingestion from processing so that your agent can focus on fulfilling the user response, and Memory Bank can focus on processing your data when it's ready to extract the meaningful information so that the memories are available when you need them. Because ultimately, you don't need memories generally. You don't need memories for the current interaction. You need them for the next interaction or the next session. You're getting ready for the future. So it's very important to actually offload this work from the agent so that Memory Bank can focus on what it's good at, and your agent can focus on what it is good at. So you've streamed events to memory bank. In the background, memory bank will extract the content that's meaningful and consolidate those newly extracted memories with the memories that already has available on that individual. So that's one key thing to emphasize here. Memories are personal. My memories are separate from your memories. So this is one area where a memory bank might be different than another traditional database because we have clear separation between different individuals' memories, and we're also performing LLM-driven actions. And I'll cover that more on the future slides. And then in the future, when the agent has another interaction with this user, it can retrieve the memories in real time to initialize the interaction between the user and the agent, so it's not starting from scratch every single time. And so the memory generation algorithm at a high level works like this. First, you have your data source. So generally, that's your conversation between your agent and your user. You're providing that turn-by-turn conversation that can be super verbose and not necessarily meaningful for future interactions. You're providing that to memory bank, and memory bank uses a memory extraction LLM to extract what is meaningful to persist from that conversation. And then we have these candidate memories that we want to figure out if we have duplicates for. So the example I always use is, what if I'm very chatty with an agent and I always introduce myself to be polite? I don't want a ton of memories that are like, my name is Kim, my name is Kimberly, my name is Kim, but I sometimes go by Kimberly. That's just going to pollute my context window and make it very hard in the future to find what's meaningful, and you just want to perform this heavy work up front. So what we do is the process of consolidation. For this specific user, we see what memories and what information we already have on them, and we decide, okay, is this information similar and we should update it, or is this completely new information and we should add a new entity to memory bank? So once we've figured out all of that work, we'll then actually mutate the database to add the new memories or update the existing memories. And let's walk through an actual example. So memory bank supports natural language memories, which you can think of as like a collection of snippets. So again, my name is Kim, I am a software engineer, I am the tech lead of memory bank. All of those would be natural language memories that are somewhat distinct and separate and like a fully contained piece of information. With this example, the user is having a relatively verbose conversation with a sales agent, and they're saying that they didn't like this item because it was chambray fabric. This is information that might be meaningful in other interactions with this user, maybe not even this agent, but other agents that are trying to recommend things to this customer. Memory bank will extract that the user doesn't like chambray fabric. This is the first interaction between this user and memory bank. So the memory is added directly to memory bank without any consolidation happening because there's no memories to actually consolidate with. But in that next interaction, there are now memories to consolidate with. So now the user says that they want softer fabrics like bamboo and cotton blend, and this is very similar information to the previous memory. So we're going to use the consolidation process in this instance to merge the existing information we have with the new information that we've newly extracted. And then lastly, you can actually enter the algorithm past the extraction point. So what if you want your agent to have control over what is persisted and what is maintained for the future? But you still want to get the benefits of consolidation so that you still have a single source of truth. You can provide these pre-extracted facts to memory bank, and we'll just take care of consolidation. So you're still responsible for determining what's meaningful, but we help you maintain this information so that you still have a single source of truth. And what information will be meaningful? So by default, we store personal information, user preferences, key conversation events, and explicit instructions to remember or forget information. But you can always personalize this, so you can use a subset of those topics. You can also define your own topics, and you can provide few-shot examples of, here's a conversation between a user and an agent. This is what I want to actually persist from it. But now, how do you actually inject that context into the context window? There's two main approaches I've seen. The first is just-in-time context retrieval. This you would generally do with skills or tools, and you would be retrieving the context when the agent decides that context is necessary to answer the user query. Another approach that we use both internally and externally is always on context. And with this, you're initializing the interaction between the user and agent, and it's not necessarily relevant to the user query, but it initializes the interaction so that you have exactly what you need to get started. This is great for pre-computed information where you're not doing any work in the background to find what's relevant. And this is why we're excited to announce memory profiles, which are a structured piece of memories that you define the schema, we populate that schema. So we extract information that fits the schema from your conversation, and then we also maintain it so that you have a single source of truth that you can easily retrieve, but then also get the benefits of drilling down into specific pieces of information to see how it was derived and how it evolved over time. And with that, I'm going to move over to a demo to show you how it works. Awesome. So to get started with Memory Bank, or to get started with profile generation with Memory Bank, all you need to do to get started is define a pydantic schema that says what you want to maintain. So this should be somewhat detailed to describe the information that you want Memory Bank to persist so that it knows what's meaningful and what's not meaningful. But you can see here, I didn't go into that much detail. Honestly, Gemini helped me create this. Then you can also provide multiple profiles, schemas per memory bank so that you can persist multiple different profiles depending on what context you want to use that information for. So for example, you can have multiple agents streaming context to memory bank, generate and maintain multiple profiles, and then use different profiles for different agents at read time depending on the context that that agent cares about. But when I'm creating a memory bank, I just provide this schema. I provide it once, and then I can continue to use my memory bank, and it will always use this schema. So it separates what the developer does, which is define their schema, define their agent behavior, from what the agent does, which is ultimately just orchestrate requests to memory bank, and we can take care of the extraction. You can also update your profile if you decide that you want to start extracting new or different information as well. And then I'm also using a new feature here called ingest events. So ingest events allows you to decouple ingestion from processing so that you can configure at what point you want memory bank to actually do the relatively expensive work of extracting context. So for here, I'm saying every 10 minutes of inactivity, I want to trigger memory extraction because it's really hard to know when an agent-user conversation is over. So I want memory bank to actually infer when that's over so that I'm not prematurely extracting context. And ultimately, you control the generation rule, and you can also flush the buffer if you decide that you just want to trigger it early. So here I'm just defining a couple of utility functions. I'm not using an agent here because I want to be very demonstrative on what I'm doing. But essentially, I'm just streaming an event to memory bank, not triggering extraction yet, and then I'm retrieving the profile that I have available on a user, stuffing it into the system instructions, then passing it to the LLM and passing the LLM's response back to memory bank so that it can process it so that I have information available for the next interaction. So again, memories are segmented by a user ID or really whatever you want. So we use the idea of a scope to identify who is the owner of a memory. And scope can really be whatever you want. So you can have user-level memories, you can have session-level memories, you can even have department-level memories. It's ultimately up to you and how you segment your memory corpus. In our first interaction with this user, we have no information available. So you can see here, the profile is empty. And in my system instructions, I'm providing some guidance on actually how to use the profile, so how it should action on this information. The great thing about profiles is I know exactly what keys might be populated, so I can give information that's relevant to those fields in my schema. Then in my first turn of a brand new session, brand new user, I want to plan a trip to Japan. I want it to be next spring. I want to see the cherry blossoms, but avoid massive crowds if possible. I got this super long response on some times to go and things to do, and that's great. And then I'm going to ask, okay, I want to stay in a ryokan. Budget isn't a primary concern, but I value authenticity over luxury. Again, another super long response with some recommendations. I don't know about you, but I hate when the LLM gives me a super long response. I just don't want buffer words. I just want it to be succinct. So I'm just going to say, let's be more succinct, please. And you can see that I'm getting a more succinct response. You can also see the profile that it's using for this new interaction. Of course, in this case, it's a single session, so I am including this context history already. But you can see how this could be important if you're doing a super long conversation where maybe you don't want the meaningful information to get lost as you get longer into the conversation. But now, let's move on to a completely new conversation. So same user, new conversation, so the context window at this point is empty. And I'm going to ask, what's the best time to go to Paris? It pulls my profile so it can see that I don't like massive crowds, that I prefer succinct and brief conversation, and generally like authenticity over modern luxury. And you can see here that it gives me a super succinct response on exactly what I want. So it's giving me a low crowd experience. I think it tells me when I can see flowers in Paris, because it does assume I really like flowers. Not wrong. And it ultimately starts with my preferences from day one, rather than me having to iterate and get it to talk slower and recommend things that actually align with my interests. In the next interaction, I can ask for hotel recommendations, and again, it gives me recommendations that are aligned with my interests. You can also provide multimodal input. So in this case, I'm providing an image of the Eiffel Tower and saying, I want a view like this, and it can remember information's textual insights from those multimodal content. So you're not saving the multimodal content itself, but you are saving insights from it. Lastly, profiles and profile retrieval is great for initializing interactions between the user and agent, but I don't know about you, I don't like black boxes. I want to see how that information was actually derived and how my information evolves over time. And with that, you can actually analyze each individual element of your profile to see the metadata of it, the time to live of each individual piece of information, and then also the evolution of that information as it got here. So for instance, I'm using memory retrieval to find the different memories that make up my overall profile, and I want to see how the priorities evolve. So I'm going to take the identifier for my priority memory, and let's see how it actually evolved over time. So in the first turn, I provided the context that I prioritized ways to see cherry blossoms without the typical high density of tourists, and memory bank extracted that I like low crowd experiences. Then in the next piece of information, I mentioned authenticity over luxury. It extracted this bit of information and then consolidated it with my low crowd experiences behavior. So you can analyze how the information changes over time, the context that led up to that decision, and then also, let's say that something went haywire and you're not actually comfortable with a profile that's extracted. You can directly mutate values within memory bank, either through generate memories or by editing it directly. And you can also roll back to previous versions of a profile. And so with that, I am going to hand it over to Jeff to talk about how AT&T is using Agent Platform in their solutions today.
Right. Thank you, everyone. Thank you for the opportunity to talk about our story at AT&T and how we've used a lot of the great tools that you've heard about so far. What I wanted to do is really kind of contextualize everything that's happening here, and then I'm going to invite my colleague onto the stage to kind of get real about everything. But if you think about what we do at AT&T, I'll talk about products, I'll talk about customers, and I'll talk a little bit about the sales experts that we have, the human sales experts that we have. When you think about our products, at first you might think, okay, it's AT&T, you sell wireless service, how hard is that? It's actually way more complex than you might think. If you think about buying a phone, there's so many phone selections you could do, there's comparisons you need to make, there's different memory aspects that you need to consider when you're buying a phone. That's not even talking about plans. If you talk about plans, we have all these different types of plans that you could potentially buy, each with a lot of nuances of what's included and what's not included. We've got a bunch of add-ons that you could potentially add to your wireless plan. That's just on the wireless side. We have fiber. Fiber might be really interesting, but then you have to think about, am I fiber eligible? Do I need a fixed wireless solution? What type of speed do I want? And then recently we announced a One Connect product, which is a bundled, the tagline of it is, why pay for internet twice? This is one connection for both your wireless and broadband service. So if you think about the complexity of the product, now kind of transition into the world of the customer and the customer mind. This is not buying a Big Mac at McDonald's where you assume consistency each and every time, consistency in pricing, et cetera. These are very high value, considered purchases that our customers have. And so what does that mean? It means that customers don't come in a single session and purchase. They come back 2, 3, maybe 4 times before they actually go and make a purchase. It also means that they're not stuck in any one channel. They don't come in through digital and stay in digital. A lot of times they'll do research in digital. Then they might go and engage with a chat agent. Then they might go into a retail store. They might call into our call center to ask some more questions about it. But you can sort of see this is a big problem that we have, is to maintain that context. And if you sort of bring it back to what we've been talking about, context is really, really important. If you talk about our human agents now, what they do is they have a really hard time understanding the context of what just happened. Our human sales experts also have a very short tenure, probably less than about a year, if you think about a chat center sales agent or a call center sales agent. So for that agent to really understand the entirety and breadth of our catalog and the constantly evolving promotions that we offer on our catalog, it's very, very difficult for them. The one thing that human agents do very, very well is they work in very non-deterministic ways. They can take an input from a customer. If the customer wants to talk about the plan first and then talk about the phone, they can do that. If the customer wants to talk about what phone that they might be interested in and the pros and cons of Pixel versus iPhone, they can do that, and then they can start talking about plans. So that's the thing that agents have. So now what we're trying to do is we're bringing the best of both worlds to AI. So the AI, we think, or we know, can perform better than these human sales agents. And the reason is they're long tenured. They don't have a tenure of less than 12 months. They have the entire history of our catalog to really understand. They can also be very non-deterministic in how they approach solving this problem. So they can sort of follow and emulate the conversation that our human sales agents have. And most importantly, they retain the context. They retain the context across sessions. They retain that context from channel to channel. So if you are browsing on our website today, and then you come back a week from now and you engage in a chat agent, that context is immediately well understood and can be picked up by that agent. So we'll get into the details with my colleague Preethi.
Thank you, Jeff. How are we doing so far? Okay, before I get started, I want to pause for a moment and let's think about your favorite coffee shop. You have been going there for over a year, every morning before work, and you have a very specific but a high maintenance order. Let's say a double hot, double shot latte with a dash of milk. So easy to remember, right? And every morning, this barista welcomes you with a factory reset mode. Hi, what can I get for you? For most days, you're mildly frustrated, but you're still okay because you're getting your coffee, and that's what matters. But then, you're having a bad day at work, and at that day, if this barista welcomes you with the same message, at that point, you'll be frustrated. You don't want that coffee. You don't even want that coffee shop anymore. You'll be rethinking your options. Truly, who would want a year-long relationship to continue like a blind date, right? This frustration is valid. In AT&T, at our scale, we don't want to ask our double shot latte customers if they have ever seen a coffee bean. And that is the exact problem that we are solving by bringing a seamless journey to our high-intent customers who are ready to make that purchase decision. So let's see. So this is our solution. It is a multi-agentic architecture which is built with the goal to be secure, scalable, and extensible. At the center of our solution is the orchestrator. Think of it as a brain or the barista from my example. When a customer interacts with our agent, the orchestrator identifies the intent, and then it redirects to the right expert. When I say experts, these are also agents, but we have defined these based on their skills and capabilities instead of product lines of wireless or broadband. We also made a key architectural decision here to split the logical layer from the display layer. So what it means, the sales master handles the magic of the conversation, whereas the formatter adopts the output specific to a channel, which could be a web or a app. This decoupled logic helps us to maintain a single context irrespective of the channel with which the user is interacting. And throughout our design, we had to place lots of importance on the context that goes to each of these agents. We don't want our token to be bloated forever. So we carefully curate the context based on the agent, and we also tweak the thinking budget and thought tokens. So we are always balancing between accuracy and latency. And our entire architecture is built using ADK framework, using Gemini LLM models, and we have protected our framework using DLP and red teaming. DLP is helpful for us to encrypt any privacy data before it goes to our LLM. And we are also decrypting it when we are getting back from the LLM. And we have powered our agents using MCP tools, but again here we have filtered the MCP tools so we do not want overexposure of the data. Now I have been placing lots of importance on the context, right? And for that we are using Vertex AI's session service and memory bank for short-term and long-term memories. And this helps our agents to always start informed and never from zero. Let's see why this architecture matters for us. We can consider a journey of a user on our platform. Like a user reaches AT&T day one on a web channel, and they have expressed interest that they wanted to trade in their iPhone 16, but they drop off. Life happens. And then the same customer reaches us again on day three on a different channel. It could be an IVR, which is our voice channel. In old world, this customer has to repeat all of their previous selections because we do not have a context. But now, since we have a long-term persistent context, we go directly to the recommendation. Again, many users get a quote and again drop off. I think many of us might have experienced this. We walk into a Costco store, get a quote from AT&T. We go to AT&T retail store, get a quote, discuss with our friends and family before making that decision. So when a user makes that decision on day 7, it could be a different channel. At that point, we already have the cart created asynchronously in the background. All the user has to do is a single click to purchase. But again, if they have to make some changes, we welcome that too. At this point, our systems have moved from guessing to remembering because we are recalling the verified facts as stated by the users. And I wanted to show how this all looks in action now. So this is AT&T's flagship app from where I can manage my wireless and internet accounts. And I have recorded this demonstration using my production account. This is already available for users. When I'm making an upgrade a mobile, like I'm saying like I wanted to upgrade a device, the agent is intelligent enough to know that I had some sort of conversation with it in the past, and it is going to give me a summary of my previous conversation, and then also an option to either continue or restart chat. And when I say continue the chat, the agent will never repeat any of the questions. It's just going to recommend me an iPhone 17 Pro Max because the previous device that I selected is iPhone 16. I wanted to take a small detour here. In telecom, we might be thinking of two big product lines, right? Wireless and internet. But the permutations and combinations with which a user can make a decision is a lot. That is where our experience is more guided. So we are tailoring the experience based on the user's profile to make it easier for them. And what the agents are doing as I speak here is to check what are the early upgrade options that are available for me and what device protection plans available, what are the accessories available, everything for a line number of an account. So we are not personalizing at an account level. We are hyper-personalizing at an individual line number level at this point. And once I finish an upgrade of a single line, I will also have an option to upgrade my additional lines of this account. And for this demo, I have selected Samsung as my second device to show how the agent is recommending a different phone based on my profile. And today, we are at the beginning stage where we have rolled this out for a single channel, for a single use case. But we have lots of exciting things that are coming up in our roadmap. We wanted to bring predictive home screens and also cross-channel synergy that Jeff was mentioning. And finally, before I conclude, if you are an existing AT&T customer here with a mobile that is eligible for an upgrade, I wanted you to try this experience because it is available for you today and see how AT&T has moved from the generic barista to a truly intelligent sales agent. With this, I'll hand over back to George for the closing notes. Thank you.